Hi friends, I welcome you all to this video. I hope that past two videos was very helpful for you to know about the auxiliary views and also the introduction of mechanical engineering drawing. So study of auxiliary view also I have combined in the past lecture 2 video. So this is my lecture 3. So in this from the next lecture 3, 4, 5, 6, 7 and 8. From the next 6 lecture we are going to see every lecture we are going to see one drawing, how to draw it. So I hope that you may get an idea how to draw the drawings, okay, how to draw the actual view projection. So in the past two videos I have explained the mechanical engineering drawing also, an actual view and also study of auxiliary plane. Okay, so now as usual you know some concepts of auxiliary views in previous PPT. In previous video I have shown some videos also. Here also you are seeing a GIF file which explains you how to draw, how you have to look the object and you have to get the views of the objects. Okay, so this is a mechanical engineering drawing subject. This 1625302, this is the code of SBTE Bihar of mechanical engineering drawing. Okay, and this is my third lecture of auxiliary views drawing. In previous two lecture, first I given about introduction on mechanical engineering drawing, and the second lecture is about study of auxiliary views and auxiliary plane. And myself, I am Arun Pandian. I am a lecturer of mechanical department in GEMS Polytechnic College, Aurangabad, Bihar. So first of all, what is the content? What we are going to see in this video? Okay, we are going to draw a auxiliary view projection in this drawing. Okay, so we are going to draw on auxiliary views projection. We are going to draw drawings on auxiliary views projection. Okay, so each and every lecture from here to lecture 8 I will show you one by one drawing. So it will be some animations and some 3D shapes are shown here, so you can understand it clearly. Okay, so we are going to learn drawings on auxiliary views projection. So first problem. Okay, so here before showing the problem, I want to tell one concept here. See, whenever you are going to solve any problem or going to draw any drawing, without knowing the concept you cannot start a single inch also. If you start it also, it will not come correctly. Okay, but if you know the concept clearly, from where I have to start, where I have to finish it. If you see in the GIF file which is seeing on the video, the shape is square or rectangle, but it is trying to push it inside the circle. It cannot happen. If you try 1000 or 100 times also, it cannot happen because of the shape is square and it is pushing inside the circle shape, circle hollow. Okay, how it is possible? It has to be after 2 steps. If it comes, he's not looking at side. If you look at side itself also, he can understand. I can put it inside. He is not trying also. So this is the concept. If I don't know the problem properly, okay, what problem I am going to solve, what I'm drawing, I'm going to draw, how to start, how to finish, from where to start, where I have to insert some things, I have to know that. Okay, let us go to the first problem. A hexagonal prism, side of base 20 mm and axis 4.8 mm long, rests with its base on HP such that an edge of the base is parallel to VP. Draw the projection of the prism on an auxiliary inclined plane which make an angle of 60 degree with the top view. Okay, so here we are going to draw a hexagonal prism, front view and top view of the hexagonal prism, and if the hexagonal prism is inclined 60 degree, how it could look like? That incline must be from the top view 60 degree. So these are the concept, okay, which I given in a block letter, the seed base 20 mm. Okay, so whenever a problem is given, okay, you have to write the given data. Keep that character always. Write the given data, which is given data means it doesn't have any rules. Whatever you are going to do, write it previously. Okay, by you looking each by each, one by one line. When I'm drawing, I will look at the question. I will draw. It will take more time. Okay, so just one by one, take it and write it separately. That are called as a given data. Here also, which I given in the block letter, just take it in each and every sum. Keep it. Okay, first one, I have to know the dimensions. What are the dimensions are given? Take it and write it. Next one, where it rests. Okay, where it is, where it lies, where it touches. Like that, words will come. Okay, where it is inclined and where it lies on. Okay, where it is rested. So here rest word is given. So rest with its base on HP. HP full form is horizontal plane, and horizontal plane means it comes under top view. Okay, and vertical plane, VP means vertical plane. So vertical plane will come under the front view. Okay, already in previous slide I explained about that. So if you have any doubts, go to the previous lecture 2, which is given by my side. So you can understand what is HP and VP and how it is called front view and top view. And another one is side view. It is called as profile plane. That explanation I given in the previous slide, previous video. Okay. So now base is on the HP. So I have to start to draw hexagonal prism in the top view. Okay. Next, such that an edge of the base is parallel to the VP. So the base is parallel to the VP. VP means it comes under front view. So front view is parallel to, top view is parallel to the front view. Horizontal plane is parallel to vertical plane. Okay. Now draw the projection of the prism on an axillary inclined plane, which make an angle of 60 degree with the top view. Okay. So now write the given data. What data are given step by step, you just write it so you can understand step by step how to draw the given data. First one, hexagonal prism. Okay, just look at the problem and then write the given data. Okay, first it is given as hexagonal prism. Okay, so second one, base is equal to 20 mm. Okay, so base is 20 mm. Hexagonal prism is there. So first we are going to draw the hexagonal prism, and second you are going to in that hexagonal prism, base must be 20 mm. Okay, each every side, that is called as base. So each every side, so hexagonal is 6, so 6 sides must be 20 mm, 20 mm, 20 mm, like that. 6 sides must be 20 mm. And next is given axis length is 4.8 mm. This axis length means how much it is extruded. Okay, how much it is extruded. So if hexagonal prism is there, if the room is there, from front it does look like square, but if you come at side it will be excluded. How it is the length of the room, total length of the room, that will comes under the axis length. Okay. Third one is base on horizontal plane. The means top view means the hexagonal base is on the horizontal plane. Okay, the hexagonal base is on the horizontal plane means top view. I have to start to draw the hexagonal view from the top view. Okay, and fifth point is base is parallel to vertical plane. So the base is parallel to the vertical plane means front view, and axillary inclined plane is 60 degree top view. Then the third object which we are going to draw, that one is inclined 60 degree from the top view. Okay, from top view it is inclined 60 degree. This one we are going to draw in the drawing now. Before that, okay, before going to the drawing, we are going to see a view of the 3D shapes of the hexagonal prism. First I am going to show how the hexagonal prism will be, and next which concept we are going to draw the diagram. Okay, sorry, drawing, and then we will start to draw the drawing. So now, so be careful. Next 10 minutes, I will keep touch on you how to draw the diagram drawings. Okay. Now we are going to see how the hexagonal prism will look like. So see here, the eyes is blinking. So for example, I have given a small changes here. So because of I couldn't do that, so that's why I kept this eye as not side view. I kept this side as a front view. Okay, so keep in mind this will be the front view. If I look it from front, how it could look like. I haven't shown the side view here because of we are not going to draw any side views here. Only front view and the top view we are going to draw, so that I kept the top view here. If I see this object from top, how it could look like, and if I see it from right side, sorry for it, if I see it from front, how it could look like. Okay, and look at the prism. So the prism, it will look like the format how you are seeing in the, this rotates. So each and every side, if you see here, the hexagonal prism will look like this only. This will be the top view which you are seeing, and this will be the front view how it could look like. So you will get an idea how the hexagonal prism. Again, I'm telling, it is rotating still. When it come here, okay, when I see this object from here, it will look like this hexagonal. So I have to draw this hexagonal, and if I see it from front view, it will look like this. Okay, okay. I hope that all of you understand how the hexagonal prism will look like. Now see the object. If I see this object from top, it will look like a hexagonal. I have to draw the hexagonal. If I see it from front, I can see the lines 1, 2, 3 and 4. These 4 lines I can see when I look it from front view. Okay, how you are seeing here, this is the front view, but I kept the eye here, that's all. Okay, I can't keep the eye front, that's why I kept the eye here. If I see it from front, I can see the lines 1, 2, 3 and 4, and this will be as a straight line. Got it? So now next, see here this drawing. Okay, this is a 3D shaped drawing. We are going to draw the same shapes in the 2D, 2 dimensionals. Okay, here I have shown the 3D, 3-dimensional shapes, but the same diagram we are going to draw in the 2-dimensional view. Okay, so this will be the top view of the hexagonal prism, and this will be the front view of the hexagonal prism, and this will be the, if the hexagonal prism is inclined from the top view 60 degree, it will look like this one, like this, how the rotating object or rotating hexagonal prism. Okay, now we are going to see the drawing, how to draw the diagram drawing. Okay, now, so one by one I will explain you. Just look clearly. Okay, see it properly. Otherwise, step by step, look at it and pause the video and draw on the paper or drawing sheet, whatever you have. If you draw like that, you can draw it easily. So first step is draw straight line. Okay, for example, if you have a drawing sheet, if this is a drawing sheet, you will divide it as a 4. This will be the front view, and here you will draw the top view, and here you will draw the side view. But in this you will draw the inclined axillary, inclined plane here, and here you will write the content, your name, registration number, mechanical engineering drawing, sheet number, scale, like that you will write it here itself. For that purpose only, you have to divide the drawing sheet as 4, and that dimension all of you already know. So draw a straight line of the mid of the drawing sheet and consider it as a x and y. Okay, draw xy straight line. Next, draw a hexagonal. Okay, so I can't explain to the mechanical engineering students how to draw the hexagonal. Okay, all of you know already. The same way, if you don't go to the YouTube and type it how to draw hexagonal, you'll get a video, and just go to the video, you can see it. Okay, and first and see it, and base must be 20 mm. By keeping each and every sides 20 mm, draw a hexagonal and mark the center point of the hexagonal. Okay, and mention the mention the each and every sides edges. Okay, outside must be A, B, C, D, E, F, and inside 1, 2, 3, 4, 5, 6. Okay, and the base must be 20 mm. This is called as top view of the hexagonal prism. Got it? So now, if you see in this diagram, I mentioned some numbers 1, 2, 3 in the bracket. Why it is on the bracket? This 1, 2, 3, 4, 5, and 6. These are in the bracket. Why it is in the brackets? Because of I couldn't see it. Okay, this A, B, C, D, E, F. I can see that edges, but I cannot see the 1, 2, 3, 4, 5, 6 edges. Means backside of the edges. I cannot see the bottom. I can see the top, but I cannot see the bottom. That's why it is on the bracket. Okay, till here it is the top view of the top view of the hexagonal plane or horizontal plane of the hexagonal prism. Okay, now we are going to draw the front view of the hexagonal prism. Draw the center line first of all. In drawing, there is some rules. You have to draw the center line in this way. One line, one dot. One line, one dot. You have to draw the center line in this way only. Okay. And next, draw a line from A to XY. To it must be touch the XY line. And start from B, connecting F. Finish it on the XY line. Start it from C, connecting E. Finish it on the XY line. And start it from D and finish it on XY axis, a straight line. Okay, it is X axis. Okay, XY axis. So XY line. Finish on the line. These 4 lines plus the center line of the prism. Okay. So now you are going to draw the front view or the vertical plane of the hexagonal prism. If you see it is drawing straight, and then here, and then connect it with the rectangle. Then from top to bottom, top to bottom. So if you see these shapes, I have explained to you by showing the shapes on the previous slide how it could look, how it's going to look like. Okay, in same way it is looking like. These two are the top views and the front view of the hexagonal prism. So the height must be 4.8 mm. I hope till here you can understand. You may understand till here how we have drawn the diagram. Now only one is remaining. If it is inclined 60 degrees from the top view, how the hexagonal prism will look like. Okay, we are going to draw that only. Draw a 60 degree line. Okay, draw a 60 degree line from the top view. That is, it is given on the problem already, and parallel to that line, draw in any distance. There is no distance. Parallel to that line, draw another straight line, and perpendicular to the 60 degree, draw a line from here, perpendicular. That's why whenever you are drawing the machine drawing or any objects or any components, or whenever you are drawing the mechanical engineering drawings components or any objects, try to use roller scale or drafter. But my suggestion, the best option, one and only, is drafter. If you use the drafter, no need to go for 90 degree, 60 degree like that. Take only 60 degree, draw it, and you can draw a perpendicular line easily with keeping the drafter in the same degree. Okay, so perpendicular to the 60 degree, and next same here, perpendicular to the 60 degree. So now this line and then it will be connected together, and now we'll get an object like this by using the dimensions. Okay, keep it in your mind. You have to use the dimensions. Okay, from center the base is 25 mm. Keep this side 25 and that side also 25, and you just connect it. So now if you see, this is 25 and straight, 25 and 25, 25, sorry, 20 mm, sorry, it is 20 mm, sorry, okay, it is 20 mm, sorry, 20 and 20 mm, okay, and last center line, and it will come as dotted line because of I couldn't see it, that's why. But if you want to draw, you can draw, otherwise if you don't want, you can leave it also. Just I shown the complete prism here. Now if you see, this is a complete 60 degree axillary inclined plane. Got it? So this is the drawing is finished. So you can get an idea from this drawings. Okay. So now the summary is, we have seen our problems solved on axillary view projection. In the next class, I will meet you with another problem on same axillary view projection. Okay, and the references I got from these books. So especially engineering graphics, it is especially for axillary views. So you can get some more problems in this same books to try yourself in the next engineering drawing also. And I will thank you all to see this video, and also the previous two videos you have seen it, and thank you for following our GPC learning online classes and also joining us. Okay, just keep in touch, follow us and join us and follow us. We will upload more videos to you. Thank you.